Hello, my name is Arthur, and in the last video we kind of rushed to get the animations all playing and didn't really give much explanation for how it works. So we'll give a little rundown on that. If direction not equals 0 and not jumping, it walks. That one's kind of obvious. And idle, that's kind of obvious too. In the jumping, um, with velocity y less than 0 and greater than 0, what's going on there is when it's jumping, its speed hits minus 350. So it's always less than 0 until it reaches the apex of its jump. And then it goes above 0 when it starts falling. That's basically how this works. Down here, when the variables are changed, I use minus 10 because it's beyond the scope of what's toggling the animation from jump to land. There's actually a mistake in these variables. As the game board is set up right now, the mistake wouldn't show. So we're going to change the game board a little bit. Let's get the tile map up. And let's put a high place. So we'll put up a high place. We'll take the player. And we'll start him off up on that high place. And we'll start, I'll find my controller so I don't have to be on the keyboard. Now I'm going to walk him off the edge, and he's able to jump when he's in the air. Well, a person may want it that way, or a person may not want it that way. Sort of depends. Some games allow you to do that, and some games don't. Now I'm going to go with a person can't jump when he's falling. So what's happening here is when he comes off of that edge, velocity y increases. So it hits the 10 pretty quickly, and it's registering that it is in the air, but it isn't registering that it's jumping. So none of that animation plays. In order to get land to play, it has to recognize that it's jumping. So we're going to add jumping equals true. Right there. And then when we start the level, now when he goes off of the edge, he should enter into the fall animation. And he won't be able to jump until he hits the floor. Now on that, I use is in air variable instead of is on floor, because is on floor gets a little bit unreliable. So one of the next things that we could look at here is the infinite inertia issue that's causing our block to be crazy. It's almost like it doesn't have any weight at all. That's happening in move and slide. Now this part is a place where I still need to cheat and do a little copy and pasting. Now what we need to do is turn off infinite inertia. So I'm just going to copy this. I'm going to paste it in down here. And then because I need to copy and paste, I'm going to comment it out and type it. Um, this is part of how I learn. I don't know if I've mentioned, but this script that I'm accessing is my previous script. And this little block here is something that I got from a tutorial myself. So in order for this to work, we need to add a variable for push. So push is how hard the player can push the block or a body. So we'll var push equals, let's call it 40. Now, velocity has more parameters. We have the actual velocity, the vector 2 for that. We have the floor normal, which is vector 2 dot up. And stop on slope. And we can see them popping up here. Stop on slope, which we'll call false, and is false by default. Then we have the max slides. So 4. The angle that's considered not being floor and being a wall instead. So that is 4 divided by pi, or pi divided by 4, I should say. Pi divided by 4. And then there's the one that we don't want turned on. It's on true by default. So we're going to set it to false, and that's the infinite inertia. So if we start like this, what's going to happen is he'll be unable to move that block now. He can't affect the block. And we'll need some code to let him be able to affect the block. So for index in get slide count, and slide count will return it'll return an array, I believe, which is it's references to the events that happened, I guess. I'm not exactly 100% certain on that one. Then bar collision equals get slide collision index. So that would be the index is the number for each loop in the maximum of 4 slide counts, I believe. So we're getting the collision events. Then if the collision dot collider dot is in group bodies, and something went wrong there, is in group bodies, Then we'll apply the force to the item we collided with. So collision dot collider dot apply central impulse we'll apply it along the minus collision normal. Oops. Times the value of push. So that will get rid of the infinite inertia. So we'll run that. And what's going to happen is we can't affect the block. We can't affect the block because we haven't told the block to be something that can be affected. So in order to make the block into something that can be affected, we have to go back to the block, into the node, groups, and we need to add it to the group of things that can be pushed by us. So we'll put it into the group bodies. Now it's a body, and we'll be able to affect it. And it doesn't have the crazy physics. We can't jump on it and throw it through the floor and stuff like that. So that fixes the way that we affect the block and other such movables we might want to put into our game. So let's quickly check the time. That took 12 minutes. That was a little bit longer than I had anticipated. So let's look at the player. I was thinking there's something that he's missing here, but I haven't gotten to it yet. So the next thing that we're going to do is we're going to look at the speed of the animations and carry on with correcting the speed of the animations. And then add a little bit to our player to get them fixed. Oh, a camera was what I was thinking he needs. So we'll kind of finish up with the character and get him functioning the rest of the way in the next video. And until then, take care.